Welcome to this video on transforming a function. Quite an unusual question that we have to do here because it's providing us with words describing a transformation that's been applied to a function f of x. And once we've moved the function according to these instructions, we've then got to give its equation in the form ax squared plus bx plus c. So what I'm going to do first is draw, well, we have already drawn the function f of x, which is x squared minus 4x minus 5, okay, in orange there. And we've also drawn in the line y equals -2, which is the first part of the instruction because we've got to reflect it in that line. Okay, so I'm going to draw that first and see what that looks like. So there it is. Okay, and you can see that it's flipped over about the line y equals -2. Okay, and then we have to take that blue curve there and we have to move it according to the vector -2, 1. In other words, 2 to the left and 1 space up. So when we do that, it will look like this. Okay, and I've dotted out the graph beforehand. So that green graph there represents the complete transformation that's described here. Okay, and we've got to give the equation of that in the form ax squared plus bx plus c. Now you may be able to guess what it is by looking at the points of intersection on the axis, the maximum point there, the symmetry about the y-axis. They all give us clues, but I want to do this algebraically starting from the function f of x. Okay, so if we take us through the steps that we've done, the first thing we did with f of x is we reflected it. Now, if you reflect a function in the x-axis, then what you're doing is plotting the function minus f of x. Okay, now if you think about it, if we had done that, if we'd reflected it in the x-axis, to get it to reflect in the line y equals -2, we would have to then move it down 4 places, okay, in order to correct the distance between the x-axis and the line y equals -2. So if we were to do minus f of x, which is a reflection in the x-axis, and then -4, that would bring the function down to where it's shown now as a blue dotted line. Okay. Now, the next thing we would have to do is move it across to the left 2. Okay, now to do that, we would have to apply a +2 to the x in the brackets, you see. Okay, because when you move the function horizontally, you have to put the number with the x, and it's usually the opposite of what you expect. So if you expect to move left, you would be putting +2. Okay, and we've still got our -4. So that's now moved it across 2 places. And if we want to move it up 1 place from where it is, we just simply add 1 to the end. Okay? So our new function g of x could be expressed like this, okay, in terms of f of x. But we're going to tidy that up now and give it in the form that it wanted. So I'm going to literally do this step by step algebraically. So minus f of x plus 2 is equal to the negative of f of x plus 2. Okay, so this means I replace everything where it says x here with x plus 2. So it's going to be the negative of, I'm going to put a big square bracket, and it's going to be x plus 2 all squared. Okay, instead of just x squared, it's going to be minus 4 lots of x plus 2 Okay, and it's also going to be minus 5. Okay, so that's the f of x plus 2 bit, and it's the negative of all of that in the bracket. Okay, but then from that I've got to take away 4, and I've got to add the 1. Okay, so let's go to the next stage and see what that looks like. Well, if I multiply out the square first of all, I'm going to leave the minus sign in the square bracket there. Now x plus 2 all squared is x squared plus 4x plus 4. Okay, now I'm going to do this part, which is to take away 4x and to take away 8. I've still got to take away the 5. Then I've got to close that bracket, take away the 4 and add the 1, which is the same as taking away 3. Okay, now let's go to the next step and tidy this up. We've got here, well, if we just gather the like terms first of all, we've got the negative of x squared. The 4x and the minus 4x cancel. I've got plus 4 minus 8, which is minus 4. And I've also got minus 5, which is minus 9. So it's x squared minus 9. And then I've got my minus 3 at the end. Now, if I multiply that bracket throughout by minus 1, that will give me minus x squared plus 9 minus 3, which is equal to minus x squared plus 6. Okay, and that is the function g of x simplified. Now it's written in the form ax squared plus bx plus c, but because the middle term, the x term, is 0, then b is 0, so a is minus 1. Okay, because that's the coefficient of x squared. B is 0 because that's the coefficient of x, and c is 6. Now, if you look at the function in green here, you can see that that fits. The reason that the x squared coefficient is negative 1 is because the function is an upside down parabola. Okay, so that's where the minus x squared term comes from. It's symmetrical about the y-axis, which explains why it has no x term in the middle, and also it has plus 6, which is where it intersects the y-axis. So it all makes sense, and it's been derived algebraically using the facts of what happens to a function when you apply these transformations to it. Okay, so that's the process that you would deploy in order to get that question fully answered. Okay.